Good afternoon. Welcome to this 1 hour session, a lecture on GNSS applications in urban studies, which is the part of the ongoing course. Okay, so I'll begin with, in this lecture, I'll be dealing about what is the need of GNSS in urban areas, what kind of GNSS receivers are available, and using these GNSS receivers, how can we capture the GCPs and what kind of GCPs are required for different purposes. Now, once we have acquired the data using the GNSS, using the GIS, how we can carry out various kind of mensuration. Then after that, I'll also deal about that what are the different urban environment induced effects which causes deterioration in the GNSS signals. What are the advantages and disadvantages while you are mapping with the GNSS. Then I'll take on some examples using the GNSS in urban areas where one can do the assets mapping, prepare the base map or the cadastral mapping, what are their significance. Then I'll also deal about that using the GNSS, you can capture the information about the assets, and using these assets mapping, one can do the automated mapping of facilities management, and or otherwise one can also, if the user's location and the asset location is known, then accordingly the location based services can be offered. I'll also try to explain that how the in various mission programs of Government of India, how the GNSS are being utilized and they have been envisaged for different purposes. Okay, so let me begin with the need of GNSS in urban areas. So when you are working with the urban areas and with the remote sensing data, primarily the remote sensing data comes in standard format which needs the correction, that is georeferencing. Now this georeferencing you can do either image to image georeferencing, or you have to, if the other geo-rectified, geo-corrected image is not available, in that sense, then you have to acquire the GCPs. Now this GCPs, if you are working with a high resolution satellite data, then you require very precise and close by, at lesser distance you require the GCPs. At the same time, if they are dealing with the coarser or medium resolution satellite data, accordingly you have to tailor your GCPs, ground control points. Okay, but this sole significance of the GCPs depends on your need. That means what are you looking for, and also it depends on the kind of satellite data which you are going to use. So once you have rectified the you have done the georeferencing of your satellite data, then later on you can do the 3D city modeling, or you can prepare various kind of maps, or you can also conduct the street views, because you have collected the information about the from the satellite data, georeferencing has been done, and then based on the three-dimensional information which has been attached to the satellite data, then accordingly you can also do the street mapping. What you can do further with the GNSS, that you can collect the various infrastructure or assets which are available in the urban areas. These assets may be on the ground or they may be below the ground. So these kind of assets mapping can be conducted using the GPS or GNSS. You can also, because the ownership details, those are also very important. So the typical cadastral maps which are typically available at 1:4000 scale, and which have got some primitive kind of projection system using the GCPs or ground control points which are acquired using the GNSS systems, and then these all cadastral maps and their parcel boundaries can be fetched, and then they can be overlaid on the satellite data to see the details, and then the further other mapping applications can be conducted. So as you understand, what I'm trying to demonstrate here, there are a variety of applications of GNSS linked GIS based operations which are feasible in urban areas. Take for example, in the recent times, particularly in the 2015 onwards, when the government of India has launched a program called Smart Cities Mission, which is trying to improve the quality of urban dwellers while improving the services, facilities, and other infrastructure available in the urban areas, right? And which emphasizes various kind of improvement in services, and these will range from various categories like improving the urban mobility, which says that the maximum travel time when you're traversing from one part of the other part of the city, maybe 30 minutes, or depending on the height of the city, if from the small and medium, if it is the metro city, one can reach from one point to another point within 45 minutes. These are the benchmarks which have been defined for the Smart Cities program, and though the standards may vary from place to place and the size of the city, but this all envisages that how, based on urban mobility or based on various kind of facilities, whether it's infrastructure, education, health and all, how these facilities can be planned or made available to the city dwellers. Take for example the healthcare facility. This smart city service parameter benchmark envisages that within 30 minutes the services should be made available to a citizen asking for the service, and the location of the dispensary or the multi-specialty hospital should be again based on smart cities program. Looking at the spatial planning, it envisages that 95% of the residences should have daily needs within 400-meter walking distance. Okay, and similarly, based on TOD, TOD is the transit oriented development, which is nothing but a combination. It's a development which takes into account the urban mobility as well as the land use under different categories. It says that 30% residential and 30% commercial in every TOD zone within 800-meter of transit station. As regard to the education facility, it says that one pre-primary school for every 2,500 residents and one primary school for every 5,000 residents, one senior secondary school for every 7,500 residents. While mentioning all these kind of smart city service parameter benchmarks, for the reason here that it requires the facilities, that means where the facilities that may be assets, that can be any building or any kind of infrastructure, versus the beneficiary. So one has to map the beneficiary, one has to map the assets. Now these all entities, they cannot be entirely drawn from remote sensing data. So some of these information have to be fetched from GNSS based instruments. So that's why this is an area where the GNSS has got wide usage. Now, as such, looking at the wide variety of needs and applications of GNSS in urban areas, accordingly, there are several kind of GNSS receivers which are available. What my point here, that depending on the need, depending on the application, one has to use the GNSS receiver. For example, if you're looking for any kind of image referencing, and that to the very high resolution, satellite data of the order of better than 1 meter or maybe half a meter. So though your smartphone has got GPS, I mean GNSS, but that you cannot acquire the GCPs using the smartphone for such a purpose, which requires some meter kind of accuracy. And that would also require some kind of correction. So, but if you want to acquire the assets information and you are and the tolerance, no error tolerance, maybe 5 to 10 meters, yes, your smartphone based GPS or GNSS will be sufficient. So accordingly, there are variety of GPS receivers which are available today, as on today, and these all belong to different categories. First is multi-constellation, where the signal and data from multiple sources are fetched for improved position accuracies, high mobility and compatibility. That means you are acquiring the data not only from the Navistar, you are also acquiring the data from Gagan, from the BDO, from the GLONASS and other kind of Navic and other kind of systems. Now, second is the multi-frequency. To improve the accuracy again, you are going to use the your instrument or the receiver has got characteristics which acquires the data in multiple frequencies. It will not only limited to the L1, it will be limited to the L2 and beyond in different sub frequencies as well. Then further to improve the accuracies, one can also use the augmentation, where while you're acquiring the data using the GNSS, at the same time their secondary unit is there which is helping the system to improve the accuracy. So this is something called continuous update to the incoming data, and then you are going to acquire the data as a nearby receivers, or you are giving as manual input for again improving the accuracy. The fourth category is the differential. Now differential means you are using simultaneously you are using more than one instrument, so that the reading is acquired in a differential manner, while one will serve as the base and others will serve as the rover or rovers. Now, once you do this kind of data acquisition, then you have to take it to the post-processing stage, and then you have to do the correction. There are another kind of GNSS receiver is assisted GNSS, where again what it does, it requires the additional data for improving the speed of processing and computation. There another kind of GNSS receiver is there, that is called software receivers, which users take as an input and it may be put in the cloud technologies or otherwise assisted by the hardware receiver, again for multiple kind of data acquisition and improving the accuracy. Okay, so these kind of receivers are available. Then based on your need, as I suggested, that if you are looking for the very high resolution, and that too you want to acquire the ground control points for georeferencing of high resolution satellite data, then you require the DGPS based points, control points. If you want to rectify the your cadastral maps, again you require the DGPS differential based control points. But you are tolerant enough that your method and your approach is tolerant for something like 5 to 10 meters. Yes, a single unit will suffice where you can collect the data, because your map scale is dependent on the accuracy of the input or the GNSS data acquired. So here it says there are defined ground control point standards, and these are given as 0th order, 1st order, 2nd order, and so on and so forth. So as I was telling you, that the accuracy of the GCPs which are acquired from the GNSS or any other classical surveying methods, they are linked with the scale of mapping. So generally the zeroth order, they are all very high accuracy and geodetic category of points which are used for in the geodesy. So, but in general, in the urban areas, zeroth order kind of GCP, normally they are not acquired. Typically in urban areas, we deal about the plans and maps. Now, these plans or maps, if you understand that we have got perspective plan, then we have got regional plan, then we have got master plan, then we have got zonal plan, and then we have got site plan. So they're all these kind of plans, they have got definite scale, where perspective or regional plans, they are at coarser scale, whereas the site plan or the zonal plan, they are at higher scale. Accordingly, one can plan the GCPs, and while you are planning for the GCP, you have to plan for also for that time, I mean, how long your observation should continue to minimize the errors, at what distance should be maintained between two GCPs. So this way we have got standards for the horizontal control points and also for the vertical control point. So if you're going for the coarser resolution, sorry for the once again. Okay, so it is linked with the quality of GCPs is linked with the point of scale of mapping and the accuracy requirement. So if it is the first order, then yes, these kind of GCPs will suffice for the 1:1 layer kind of mapping. If it is the third order, then you are dealing with the large scale kind of mapping, or the order of 1:5,000. So in general, there is a kind of mathematical relationship is there which describes the horizontal accuracy, where the horizontal accuracy is the A is the denominator and S is the propagated standard deviation, and which is depending on the which is acquired or the statistically adjusted based on least square adjustment, and D is the distance between the survey points. Similarly, there is a relationship between the vertical points, that means elevation accuracy. The first order defines in the relative accuracy will be 0.5 and the third order will be 2.0, where it is mathematically described as B is equal to S upon under root D, where the D is the approximate horizontal distance in kilometer between control point position, and S is the standard deviation between the control points with least squared adjustment. With this mathematical relationship, I'll also try to simplify with the example that as a matter of thumb rule, in general, the scale of mapping versus the accuracy, if you take it, then the accuracy on any scale, planimetric accuracy, that is the horizontal accuracy, is the 0.25 millimeter of the scale. Okay, so if it is the 50,000 scale mapping when you're doing, it's the planimetric accuracy or the horizontal accuracy will be 12.5 meter. If you are doing with the vertical accuracy, the vertical accuracy is the h by 3, that the h is the contour interval. Accordingly, if you take on some of the programs like Amrit. Amrit is the major mission program which has been planned, which is ongoing since 2015, and it is dealing about to improve the quality of services in urban areas, which is primarily meant for based on 11 reforms to improve the quality of urban dwellers based on providing better sanitation, water supply, and allied thing also for the master plan preparation. Now, what this Amrit program envisages, it envisages that the utilization of remote sensing data of the resolution of the order of 0.5 meter or better. So, in order to georeference the this kind of satellite data, you require DGPS based ground control points. So while this kind of points are acquired using the DGPS, it states that the accuracy of such points should be better than 0.5 meter positional accuracy, and the height accuracy should be better than 0.5 meter. Also, this program, as per design a standard document which is available on the Ministry of Housing and Urban Affairs Government of India website, that it also describes that what should be the distribution of GCPs using the such kind of system. It says that the GCPs should be uniformly distributed in entire your area of interest. There has to be one GCP for every 5 square kilometer, and particularly in the overlap area of the images, GCP should be available for proper stitching of the adjacent images. And then, but while you are taking the GCPs, one has to also take into account that the GCP should be available preferably on the non-variant features. Non-variant features mean the features whose characteristics does not change over the period of time because of the seasonality or otherwise. Okay, now such kind of GCPs, when you are acquiring this, will help us. It helps the planners and engineers who are working in this Amrit program for georeferencing of the satellite data, and then to extract the information under 8 categories. So these all 8 categories are available in the design standard document. You can kindly visit the document which is available on the Ministry of Housing and Urban Affairs Ministry, and it is useful for preparing the master plans for almost 500 cities in the country in the phase 1, and the phase 2, which is already in the plan, which is going to be launched or already launched, where which is meant for the small and medium towns in the country. Again, this kind of, because these small and medium towns will have got the limited growth, urban growth, as compared to the initial cities which are taken in the phase 1, then again the accuracy standards again will further improve. Right now what I'm showing the discipline standard is for the phase 1 cities. Okay, so accordingly, so I'm talking about the errors. Okay, so far I have talked about the what is the need of GNSS or GPS in urban areas. Then also I have talked about the what is the need, and then this need will be to georeference the satellite data or to capture the point, line, or polygon based information. So when you are capturing such kind of point information, that will be as control point or the point information as asset. So then accordingly, types of depending on the type of GNSS receiver, accuracy will also vary depending on the type of GNSS receiver, how much time you are using. That means period of observation for a given point, and then depending on the kind of instruments, and then based on the signal or constellation which you are using, your GNSS is compatible or which is available. So accordingly, depending on such kind of facility, we know that the GNSS frequencies are typically like L1C or the L1S, L2C, and L5. So it decides about, in the previous years, we had, I mean, when it was called as GPS, we used to have the standard positioning system or the SPS with selective availability. So selective availability means where the system owners, they used to switch off some kind of signal frequency, and the entire frequency range was not available, and that causes the deterioration in the signal and the accuracy. So in that case, the accuracy or the error obtained was inferior. Subsequently, then we have got the arrival of high resolution satellite data, and then people started capturing the asset based information, and then subsequently we started receiving the DGPS of the second generation. We start which came into the being in the new millennium and beyond, and then the newer techniques and the newer kind of instruments with the multi-constellation, as I was discussing. So those kind of things came up where the accuracy has got improved to the almost to the centimeter level. So depending on such kind of characteristics in the of the receiver or the facilities, the accuracy is varies. But at the same time, one has to be cautious while working in the urban areas, because basically the GNSS signal, when it traverses, when it is captured by the instrument, and then the satellites in the orbit, the linkage is maintained, the signals, what it passes through the atmosphere causes a delay in the GPS signals. Okay, so this delay that translates into the position error. So then this kind of position error that needs the correction. Now, some errors are also when you are taking into the post-processing stage, again, because of the several reasons, again, such errors are either comes into the picture or they are corrected. And then we have got the arrival of DGPS, that is the Differential Global Positioning System, or DGNSS, which has helped us for minimizing these kind of errors and then achieving the high quality the control points or the data correction. So accordingly, as I was telling you, that in the urban environment, because of the density of the buildings or any kind of shadow effect, that causes the signal deterioration. Now, what happens in a dense urban setup? You have got the tall buildings. No, your instrument is somewhere on the street or any open area, but even then, because the buildings are close by, what will happen that there will be multitude kind of errors which will creep in, and that will deteriorate the signals which are received by the GNSS instrument. And these errors will be like multipath, or the attenuation or blockage of GNSS signal, or interference. In the multipath, what happens? Both direct line of sight signal, reflected or diffracted, that comes and that is received by the system. So what happens that you got the signal which is coming and it is hitting the part of the building, and this again the signal is also hitting the surface. So this kind of multiple signals which are causing the multipath, that is received by the instrument. So that causes some kind of attenuation or deterioration in the signal. Again in a second case, what will happen, because the buildings are close by, there will be blockage of the signal. Okay, so this blockage of signal means you will not require the required number of satellites, and that will dilute the PDOP and GDOP. I hope in the initial lectures this has been explained to you, that is the precision dilution of position or the geometric dilution of precision. Okay, so that dilutes the accuracy of the data received, and that subsequently causes the deterioration in the accuracies. And then, because what may happen, that presence of other signal sources which are prevalent in that area, that will also cause the interference. So in the urban areas, such kind of interference, because of the presence of building, or because of the presence of the tall trees or other structures, that causes the deterioration, and then that requires mechanism. so that we can improve the accuracy of the data acquired. Such a mechanism will be based on, if you kindly recall that when I was mentioning about the GNSS receivers, accordingly, either you have to resort to the differential mode or you have to resort to the augmentation. Like, for example, we have got the, I hope you are aware about the Gagan kind of system, which is helping us to improve it. That is the satellite based augmentation system, and rather than using the slightly cumbersome DGPS, it helps us to improve the accuracy by using the Gagan based system. Okay, so as such, with its GNSS offers several advantage while you are working for the data acquisition. See, conventionally, what we used to do, we used to do the surveying using the conventional methods. It may be chain survey with the total station, or based on theodolite, etc., etc. Okay, they have got their own advantage because high accuracy and large scale mapping can be conducted, but they are very time consuming, and the survey can be conducted based on the limited line of sight. So if you want to capture the large areas, and when you have got the satellite data which has got the typically, even the high resolution satellite data, a frame will have the swath of nearly 10 kilometers and 10 kilometers. You think about the 100 square kilometer, and when you want to do the georeferencing, and when you want to georeferencing with the classical surveying methods, and when you have to acquire the GCPs, think about how much time will it take. That is why the GNSS receivers that help us a lot in a limited time and then you can acquire the GCPs, and then you can do the correction. Okay, so that is why mapping with GNSS has got several advantages. That is easy to use for field data collection, and then modern units, they require very little training. Okay, it has got high accuracy, and if you want to further improve the accuracy, you can do with the differential based mechanism, or you can do the augmentation kind of thing. Okay, so this collected data, that will go directly into the GIS, because GIS is georeferenced, and that has to be globally or locally georeferenced. If you are acquiring the data with the conventional methods, no, then again you have to do the transformation to bring it to the some global or local scale. But this kind of mechanisms already available with the GNSS based data collection, and then worldwide availability. But at the same time, it has got certain disadvantages, or one has to be cautious. I'll not say it is entirely the disadvantage. One has to be cautious while collecting the data, because after all, when you are working with any kind of advanced techniques, it has got its own limitations as well. Those limitations that one can overcome and with various methods and tools available. Okay, like the post processing of the data, etc., etc. Okay, so as I was telling you that in an urban environment, the signal is obstructed because of the presence of the tall buildings or any kind of tall trees, etc., etc. Okay, so and then they, depending on the need, I mean, if you're working with a very high resolution satellite data, so GNSS accuracy may be insufficient. So then, if you want to do the differential correction, then certainly it will require long observation time. So you have to you have to fix a base, and then you have to move around with the rover. So if you are doing so, depending on the size of your area of interest, you have to maintain the equilibrium between the base and the rover. Okay, at the same time, you have to also optimize the number of control points. That is why they are slightly costly affair. Okay, it requires more time. So longer the distance between the base and rover, your observation time will increase. So if you are taking with the single unit, I mean, your unit will stabilize within, say, few minutes only. The unit will stabilize, and a single point data can be acquired. But you want, when you are working with the DGPS or DGNSS kind of instrument, then you, depending on the distance between the base and rover, your observation time will increase. Now, in urban area, because you're working with a very high or large scale mapping, high resolution satellite data and large scale mapping. That is why to frequently cover, I mean, in a shorter time to cover the large areas, you may require one base and many rovers, and that is why it requires more than one unit. Okay, and depending on the kind of applications, you'll also require some kind of training if you're working particularly with the high resolution satellite data. If you're working with the core solution satellite data, your even mobile based no GPS will also be sufficient. Now once you have collected the such kind of GNSS based instrument, you can take into the GIS, and then you can exploit the benefit of the GIS for doing various kind of analysis. As I was mentioning in the beginning of my deliberation, that you can find out the relative location of the beneficiary and the asset which is available. So accordingly, if you want to traverse, one wants to traverse between the 2 points. What is the best route? What is the nearest facility which is available to my place? How much is the service area? There is a school or hospital, and as per the government of India or any other norms, what is the service area, which is the area which is devoid of the service and where the people have to walk along. Okay, and then further you can do the mensuration, like you can measure the length, you can compute the speed, you can compute the time. Okay, so these kind of impedances you can build upon, and then you can do the facilities management. Okay, so that is coming in the subsequent slide. So as such, as you understand in the urban areas and as envisaged, also envisaged in the smart cities program. So what then is the smart city program envisages? It based on various kind of norms and strategies which have been prescribed. It attempts to improve the quality of the life of urban dwellers. So while I'm located in any urban area at a point, then I want to avail some kind of service. My position has come. That position has come because I'm having the smartphone, and a smartphone has got receiver. Okay, or otherwise I'm looking for the very high precise control point. I may be having very advanced instrument as well. So I have got my location data. Now this location data is available, but at the same time I want to do the some kind of analysis. How far is the facility available? Where is the nearest facility available? How to go to a particular point? I'm a tourist, okay, and then I want to visit the area, places of interest, or there is an emergency, I want to visit some hospital, etc., etc. That is why in the context of this kind of urban environment dependent analysis, to so that the beneficiary and the service provider, they come to close by, and they meet each other and then meet the demand. You also require other technologies, and those technologies like internet, then wireless communication, and then mobile devices. So, and of course, the topic of this lecture is the GPS. So if you have got all these technologies, and that is why the convergence, when it happens, it helps us to build the service and to do the facilities management. So as such, this all kind of data which we have fetched, it helps us in the urban areas for assets mapping. Okay? So in the using the GNSS, you have mapped the assets, and then you are able to find out, and you can attach the attribute depending on the site characteristics. You have got a mobile phone, or you may have got advanced instrument, and then you can do the find out the location, status, or the condition in the attribute table. Now, what you can do further, you have got a mobile app which built on your mobile phone, and then you have done the distribution of this mobile app. Now several people, they are doing the data collection, so that is called as crowdsourcing. So once you have done, then within the assets you can do the mapping of utilities or amenities. Okay, so as such, there is a distinction between the utilities and amenities. Utilities are those which are useful, which are in fact essential for the day-to-day life. But at the same time, amenities are those which add to pleasure. They're also equally important. I'll not say they are less important, but at the same time, they add to the pleasure as well. Okay. So in the asset management, what you have done these kind of data collection, and then what you're doing, one can do the asset management. So asset management is nothing but systematic process of developing, operating, maintaining, upgrading, and then disposing of assets cost effectively. So once we have done, so as I was telling you that typically in the urban areas, the within the assets, the subcategory is the utilities, and utilities, as I was telling, that there will be water, gas, electric, telecommunication. So without these things, no one cannot imagine the day-to-day life in an urban area. In general, they are very, very essential. But we have got the amenities like the which will be pertain to the category of religious, community, entertainment, and so on and so forth. Okay, so but there are other categories like educational, health, medical, which are without that one also one cannot think the life, you know, because in the case of emergency, you require medical facilities, you require educational facility. Without, unless the children they study, how the society will grow. Okay, so that is why there is no clear cut definition between the utilities and amenities, but both they belong to the assets in an urban area. So typically, different kind of assets in an urban area would be like land, building, infrastructure, and then different kind of information technology assets, plant and equipment. So like within the land, you've got garden, park, sports ground, playing fields, etc., etc. Within the building, you've got the heritage listed sites, libraries, etc., etc. Within the infrastructure, you've got transport network like road, parking space, etc. You got the water utility network, you have got bridges, airports. Within the information technology, you have got various hardware and software. Within the plant and equipment, you have got vehicles. Then you have got several kind of equipment which are plying on the street, and then they're trying to come close by to the beneficiary. Okay. So as I was telling you, in the recent times, there people are developing the mobile apps, and that is the convergence which is happening. In fact, so I was mentioning about the convergence of the technologies. Now, such mobile apps and the smartphones built on smartphones, they have got built-in GPS. It has got telecommunication facility. It has got the internet, and then that's how you have got the no, I mean, you have got a menu where you can collect the information under various categories about the assets in an urban area, and that will be point, line, or polygon. Okay, and then once you have done it, then you have also taken the coordinates, and then you have taken the photographs, and then you are you are working with the internet, and then you upload that kind of information to the central server. Okay, so that's how these kind of asset mapping, where the GNSS or GPS is one important essential element that is captured, and rather than using the conventional questionnaires and then taking the conventional means, okay, and then we take enormous time. The mobile map is an integrated entity which helps to quickly capture the information. So as such, there are several examples within the country or outside, where such kind of convergent technologies, they have been where the GNSS system is being used to capturing the information. For example, in the Indian Railways is collecting the information, and then it is collecting the information about the various its assets. Okay, so assets means where all its physical assets, maybe individual systems, and then such kind of assets, when it is present here, then how this can reach to the destination, or how it can reach to the beneficiary. Another example is the e-panchayat. Okay, so e-panchayat, again, it's again a mission program under the government of India's Digital India program under the e-governance plan, and it is the part of one of the 31 mission mode projects. Okay, so again, it is intended to collect the panchayat level information using the such kind of system. Another good example is the RAPDRP. So RAPDRP is the massive program which has been taken up by the government of India within nothing but restructured, accelerated power development and reforms program, which is trying to using the GNSS and GIS to map the facilities and services to minimize the losses. Okay, and then this kind of powered GIS that has been planned, where it has, first of all, it is helping to minimize the losses, it is creating alternate employment opportunities, and is helping the country to further its growth. Okay, so as such, if you have collected the such kind of assets mapping, no, if you have conducted using the GNSS kind of system, no, then you can do subsequent analysis. Okay, you can do the modeling, and such kind of modeling is it leads to the several use cases and studies. So what you can do, you can find out where the those hazard prone areas are located, what is the risk that may be likely to get inflicted. Okay, and where are the vulnerable population which is located. Okay, and then subsequently it will lead to the risk assessment and mapping based on simulation and modeling. If that is so, which are the assets that will get, all the infrastructure based on intensity of hazard that will get affected? If that is so, and then before that it will require the assets in inventory, and either as a precursory you can do the public awareness campaign and also carry out evacuation zones. Okay, so that's how the end-to-end utilization, that means in a normal day-to-day life, using the GNSS, these kind of mapping can be done. It can be beneficiaries location can be mapped, and then the one can plan for the how far they are located to each other, but at the same time, in the case of emergency, how this GNSS can be utilized so that the losses are minimal. Okay? So I was mentioning about how these all GNSS, they are, and its GIS has been used, propagated for the various Government of India mission programs. So I'll particularly like to mention some of the examples here, and one such example is the Bhuvan Panchayat. Okay, this project is a offshoot of the project that is the space-based information support for decentralized planning, which has got the creation of the large-scale satellite database, and also various kind of other spatial database which will be useful for the spatial planning. Okay, and this planning will be rural planning and can be also for the decentralized planning. Okay, so that the data is available. Typically the planning in an area, typically the land use plans conventionally were built based on map sketches. So in the modern time, though we know in a small area, in a village and surroundings, the village dwellers, they know their surroundings very well. But when you want to take it as a project basis, no, even a small area of the tune of the order of micro watershed of the 500 hectares, that will also constitute a large area where preparation of maps are the prerequisites. So such kind of endeavor is important, which is helping in the decentralized planning. Within this project, no, the 340 kind of assets, they have been envisaged to be mapped all across the country. It's a mammoth task which has been targeted and which is ongoing under the e-PRIS program. Now, this all 340 kind of assets, they are built into 5 categories, and those are natural resources, productive, civic, human resources, and governance. Okay, you are seeing the part of the sublist as well. Total, there are 340 kind of assets. No, think about some mammoth tasks across the country. But if you got these kind of facilities, no, available and they are mapped, think about its benefit. If you know this kind of thing, no, facilities available and the benefit, I mean, if they are mapped, you rather than inventing and reinventing, now you have got entire database available in a single platform, and that will be helpful for subsequent planning exercises, which are again the data collection is done by the individual entities at their own system, and then it's like revisiting and then for the same purpose creating and recreating. That will minimize, and ultimately it will reduce the cost of plans preparation, straight where it will lead to the development exercise for the holistic development of the our country. Okay, so as such, now this all kind of assets mapping using the GNSS or conventional technologies like the CAD, it leads to the system called AM and FM. AM and FM is the automated mapping of facilities management, which is the sub branch of the GIS, okay, which helps to map the facilities and the services. Once you have done the mapping under the AM, then the facilities management come into the picture, how to manage those facilities. Okay, so this is nothing but suppose you have got a facility like a school or college or medical facility, then you have mapped it. None, you have got on the GIS, then we can find out the service area, you can find out the deficient zone, or you can find out the surplus zones, and this how you can do the further planning exercises. Okay, so this automated mapping and facilities management is quite helpful. Let me take you some of the examples. In a typical area, we can map the educational facility. Now, based on norms or based on variables, we can find out if it is the 5 for each location of a school, and suppose it can serve to a distance of the children should not walk more than 500 meters, which will be the how much will be the beneficiary area, right? So you are seeing the innermost circle here, and that is the beneficiary area. Okay, so if it is the 500 meter, you see still large area where the facility is not available, though the urban population will be not be there, but you can link it. The school location of school overlapped on the population or built up density. Okay, so the relationship you can build if it is the 500 meters. Now if you take to the 500 meters, now you're seeing the lighter green area, the facility, no, that larger area got benefited, but even then you have got the other areas where those are devoid of the facilities, or the children have to walk along. Okay, if it is the 1500 meters or 1.5 kilometers, again the buffer zone will increase, larger area will be served. So accordingly, if it is the 500 meters, then 27% will be the beneficiary. If it is the 1 kilometer, 56% of the population are the beneficiary. If the norms are 1500 meters, then 87% of the population shall be the beneficiary. Okay, that's how you can create a, I mean, based on assets mapping, based on AM and FM, then you can find out which are the beneficiaries, where the beneficiary is located, where the assets is located, and based on GIS tools, you can find out the how much the area will be served and which are devoid of the facilities. Take another example, city park. Okay, so based on city park, then if it is the norm is 1,001 kilometer, then innermost circle. If it is the 2,000 meters or 2 kilometer, a larger area will be served. 3 kilometer or much larger area will be served. But even then, because there is importance of neighborhood green in no, because a tree or green cover, if it is 2 kilometer, 10 kilometer away from me, it is good to the environment, but it has got lesser benefit to the in the neighborhood. That is why urban green spaces, they have got their neighborhood linkage, right? No, isn't it? So that's why there is beneficiary and the look and the user and the asset, they've got linkages, how far and how close they are by. Such kind of GNSS based data collection and GIS based tools helps us to find out that how much they are correlated to each other, right? So as such, now once you have mapped the location of different kind of assets, then further the question comes how to reach to that asset. I am located in one part of the city, but the asset what I'm interested in other part of the city. That's how in the case of urban mobility, again the GNSS has got application. Okay, first of all, you're already using while you are availing the taxi services or the eateries or other active door services, those service providers, they are using this all kind of location based services. So I'll come to the location based services where it is important to know not only the location of asset but also the location of the user. Both may be mobile and or the both may be immobile. Okay, so but either way both are assisted with the GNSS or GPS. That's how that they know each other's location and they can reach to each other. So that is why the real-time location, where is my nearest, where is the nearest accident site, where is the nearest facility available, I'm located at the part of the city. So both locations are important. In the AMFM, it was only the location of the asset, but here the asset and the beneficiaries both their location is important, and that's how the tracking, traffic monitoring and the real-time vehicle location information can be obtained. Okay, so that's how the location-based services come into the picture. So the location-based services or LBS are the applications that depend on user's location to provide a service information that is relevant to the user at that time. So that is why it is the application which is becoming more and more popular, and in fact all of us are using in these days. So where we are availing different kind of facilities or we reach to a particular facility while you are availing these kind of mobile apps. Okay, so this is nothing but a convergence of the different kind of technologies. Okay, so as such, this location based services, no, using this one can do the traffic information, traffic queue alert. See, you are doing it when you are working on the Google map, right? No, so you know at what point you are and where is the destination, and on the way where is the traffic congestion is there, or roadside service, or the destination information, or the recreation spots, or the weather updates, such kind of thing. No, we are it is in the practice. So such location based services, no, there are two types. One is the push and second is the pull. In the push type of service, the user receives information from service provider. Okay, user receives information from service provider. In a pull type, user seeks the information. Where is the nearest restaurant, ATM, etc., etc. Okay, so as such, in the location-based services, we use several GIS based functions like position, route, proximity, then suitability, inventory, pattern, distance. So many things we use it for various kind of purposes as has been defined. And this LBS, no, they are being used, we are using it in our day-to-day life for, based on maps and to navigate, okay, for tracking the services, for seeking the information, or various kind of application oriented services. Okay, so that's how the location based services are very, very important. To cite some example, I mean, because the time is limited, I may not be able to show you entire range of services you are already aware. In fact, you are already using it. For example, fire, there's a fire, occurrence of fire, and the fire station or fire brigade has to, or the motor has to reach to the vehicle, has to reach to the fire affected area. So accordingly, how much time, because of dowsing station has no that vehicle has to reach at the earliest. That's how that time is the money here. Okay, so accordingly, based on time as impedance and the location of the distance between the fire station and the fire affected zone, that location and which is the best route, and you following that best route at how much time the vehicle can reach to the spot. So that kind of mapping can be conducted. It may be time dependent, it may be distance dependent based on the impedance that is served. Okay, and some more examples are available where you can use the LBS based services. Okay, so as such, with this background, now I'll discuss here that how this in the Government of India mission programs, how this GNSS, AMFM or the LBS can be used, or they are being planned. So under the Amrit mission, okay, Amrit, as I was telling, that is the major mission program of the Ministry of Housing and Urban Affairs, which envisages mapping the utilities. Okay, so under the 11 reforms, mapping of utilities like water supply network, drainage, sewerage, electricity supply, gas distribution, etc., they are being planned for mapping. So once you have mapped it, then what you can do the subsequent exercises as I have shown in the previous slides. Okay, so then this Amrit document, no, it has beautifully listed that what kind of assets under the water supply, what should be the symbology that should be followed. It's the water supply, stormwater and drainage network, sewerage network, power supply, gas distribution network. So what is the purpose of mapping of all these assets using under the Amrit program? To find out, as the example which I cited in the previous slides, no, first of all, to find out service level gap. Now you know it, once you have mapped it, that based on the norms and the benchmarks, no, you can find out where the gap areas are there. So once you know the gap areas, see, you can do it manually, conventionally, but manually or conventionally, you will have no one's own prejudiced. No, one's own prejudice will be certainly get built within the decision. But when you are working with the GIS, such kind of prejudiced decision will not be taken in general. Okay, so once you have found out the deficient zones, then you can find out how to bridge the gap. Then you look for the alternatives. Okay, so what kind of alternative, whether new school has to come, where has to come, new hospital has to come, where has to come, which are the new routes where the bus can ply, okay, or where the new tube well can come. Okay, so these kind of things are emerging, which can be taken up under the Amrit mission, right? And then you can examine the alternatives, find out the cost, and then think about, yes, suppose there is a water congestion or water supply is short. Such water supply is short, whether the water recycling is a better solution or augmentation of the facility through other means, it is a better solution. Okay, so such kind of out of box thinking, or if it is the waste management, so where the vehicle should ply such a manner that the cost is minimized. You have found, you have mapped the location of dustbins, Now you are going for the primary collection and the secondary collection. What should be the best route so that the trucks operate in an optimal manner, right? So that's how we have developed one app that is called Sankalan. Okay, Sankalan is helping us to map various kind of assets which are the land uses which are available in an urban area. Okay, so using this app, one can do variety of data collection in urban areas, which is primarily intended for use in the Amrit mission, but you can use it in general for various urban planning exercises. And this Amrit Sankalan app is free to download from IRS website. Okay, you can visit the front page of the IRS website. On the down below, you'll find the Amrit Sankalan app, and you can download APK file and you can start collecting the information. So assets mapping is one, right? So, but also in urban planning, we have to prepare the maps. Why? You have to prepare the maps for better and alternate land use planning, right? So when you're doing preparing the map, the first thing in the maps preparation is the base map generation. So in the base map generation, what we do, typically the base maps contain the information on administrative boundaries, street names, then several other attributes, right? So what you have to do, first of all, after doing the georeferencing based on characteristics of the satellite data, then you start capturing this all kind of details. Then subsequently you start preparing various other kind of maps. So once you have prepared variety of other maps like land use, land cover, soil, etc., no, and then all these maps have become the part of the GIS database. And it is also important in the context of urban planning. We also have to see, because you have to prepare the alternate land use plans. Okay, so like the master plan or otherwise, in that case the cadastral information is also important. So as I was telling, know that the cadastral mapping, when you're doing, you have got this kind of cadastral maps are available, okay, which will have a table and also the map, right? So what you have to do, then you look for the high resolution supply data after doing the georeferencing, and the georeferencing of the also the blueprint cadastral maps, and then it is a slightly a tricky process that itself requires a separate deliberation. Then what you have to do, you have to bring all these parcels on the supply data. There will be certain aberrations at certain places. Those aberrations you have to correct, and then the parcel boundary and the ownership details, they come on the satellite data. So once you have done, then this also becomes the part of the overall planning exercise. And that's how the government of India has brought another massive program called National Land Records Modernization Program. So here it is envisaging the digitalization of the cadastral maps, okay, which are usually available at 1:4,000 scale, right? And then once you have done it, then the subsequently its utilization can happen in urban planning processes. Here very important that the digitalization of this kind of cadastral maps, no, again as I'm mentioning that it is a cumbersome process, and there are several kind of errors which might come in because of difference in the projected and the geographical area as given in the table, that is the attached table data. That's how the various kind of trade-off mechanism has to be built to bring the such kind of digitalization mechanism, right? So once you have done this kind of maps generation, what the urban local bodies, they are also trying to capture the urban specific details, and using the either the rental value method or using the capital value method, or the unit area method, advanced method like unit area method, which it depend on use factor, occupancy factor, age factor, or structural factor. So such kind of information, which will certainly require the use of GNSS, one can go to the ground and then collect the field specific, parcel specific, building specific information, and then this can lead to the GIS based property taxation. One can, because in the slum or squatter areas, no, where the houses are very, very close by, in such kind of dense built up, what happens typically, that buildings are so nearby and the population is so dense, typically even the high resolution satellite data will not yield the sufficient information, so to, and which is required for various development planning exercises. That's why if you want to know the what kind of sanitary facilities are available in such kind of localities, what kind of roof material is available in such kind of, and that too house, I mean house to house basis. So that is why you have to again, with the help of the mobile app, and which is aided with the GNSS, then you can collect such kind of information, and one can do the slum or squatter based planning exercise. Okay. Here it is also important that in urban areas, no, typically when you are mapping the various kind of urban water utilities, then typically what happens that in urban area, for any there's an overhead tank, its command area, we find out the population, and then we multiply that population and the per capita water demand, which is typically depending on the kind of the city it will be, and the kind, it's a urban or rural, may vary from 135 to 150 liters per capita per day if it's urban area. And then that's how the total water demand is computed. But you have to keep in mind, because the water flows follows the gravity while it moves from reservoir or sumps or overhead tanks to the beneficiary location. So such kind of such kind of thumb rule based mechanism does not work out, and you'll find that in the downstream tail end areas people are devoid, or there is pilferage and so forth. And that's how though the facilities are sufficient, appears to be sufficient, but still the people are crying. That's why the one can map the such kind of assets like the overhead tank, sumps, reservoirs, and other facilities available in urban area. One can use the GIS-based hydraulic model, which are freely available like EPANET, and then one can do the such kind of modeling exercises and find out how much the facility is available, and accordingly that where the which are the deficient zones where the further facility augmentation is required, because the underground water utilities, they are available below the surface. So what one has to do, one has to utilize the instrument like ground penetrating radar, which again is a remote sensing based instrument, works on the principle of micro remote sensing, which emits the signal below the surface while it traverses over the surface. And then if you've got a GNSS mounted on top of the GPR, then underground power utility, underground water utilities, or the power utilities, or any other asset which is placed below the ground in a non-destructive manner, its position, that is X and Y and Z, that can be obtained in the conjugate use of GPR and GNSS. And then subsequently, okay, subsequently one can do the assets mapping and also the facilities management. So already I was mentioning with various other programs given by the government of India, like the tourism GIS. Here in this example, which is available on the Bhuvan, various kind of places of interest of tourist importance that has been mapped using the GNSS and also mapped using the satellite data. Okay, and they are available as a tool, as an application on the Bhuvan platform. Another example is the municipal GIS. Okay, where in the municipal area several kind of facilities, they have been mapped, and also the beneficiaries, their location is available, and that will serving as the municipal GIS. Like for example, like the parcel boundary, electricity availability, which all areas where the electricity is available, street lights, which all area which have got the street light facility, where the water supply is available and other facilities are available in urban area. And as I was mentioning that the government of India is extensively using the GIS and along with GNSS for mapping various assets, power transmission assets, and then the aim is to, once the assets have been mapped and they have been being monitored using the ICT and GIS based tools, it is helping to reduce the transmission and distribution losses, and also it is helping to as a whole to increase the revenue, and subsequently overall aim is the growth of and development of the country. Okay. Another good example is the rooftop solar potential assessment. Here in this example, what one can do the georeferencing of the satellite data, okay, and then one can map the rooftop. Once you know the rooftop, then you can also compute the satellite data driven solar irradiance. So now you know how much is the rooftop area and how much the solar energy is incident on any rooftop. If you multiply these two factors and then multiply the efficiency, you can find out how much the energy that can be tapped using the renewable energy that can be tapped using the solar panels, right? So as such, I was mentioning about the government of India is using the GNSS in variety of programs as like the Smart City, Amrit, Swachh Bharat, and Hidayat. Under the Smart City program, no, you have got the under the strategy, it contains 4 strategies that those are retrofitting, redevelopment, greenfield, and pan city. As such, there are a variety of GNSS applications in urban areas. I like to particularly mention about the pan city, where one can assess address the waste management, urban utility, urban amenities, water management, and others, where the facilities can be mapped and the facilities management can happen using the GNSS. Atal Mission for Regeneration and Urban Transformation, that is the Amrit program, where already in the previous slides I have mentioned that the GNSS has got wide application. I like to particularly mention here that IIRS along with Town Country Planning Organization, we have developed the curricula for GIS based training and capacity building program across the country, and this kind of curricula is helping the planners and engineers across the country how they can utilize this upcoming technology in their day-to-day programs. Okay. Another good example is the Pradhan Mantri Awas Yojana, where using the mobile apps and also GIS database, where individual beneficiaries know location, they are being mapped using the GNSS, and their photographs are captured, and this database comes on the screen, and this is one such example is available for the Andhra Pradesh on the Bhuvan platform. If you type Andhra Pradesh housing project and then and Pradhan Mantri Awas Yojana, where you will find this glaring example where such locations, no beneficiaries location, their houses, they have been mapped, and then it is helping to find out especially where all beneficiaries location are located. Another good example is the Hriday program of Government of India. Hriday is a major program where the 12 cities across the country they has been taken up, and which is aiming towards mapping of heritage within the cities, those cities. Which heritage, you know that there are two types: cultural heritage or natural heritage. So both kind of heritage, no. So they are being planned to be mapped in such areas in 12 cities, so that you can better planning. So because those cities they contain the heritage of importance, to make it more tourist friendly, and also so that such cities know they attract more tourists, the facility increases, and then they will become the further it will add to the revenue, you know, which can be enhanced because of the enhanced footfall. So that's how that is the aim of the Hriday program. Another very glaring example where the GNSS and GIS can be used is the Swachh Bharat program mission of the government of India for the effective solid waste management. You know that typically when we generate the waste from any household or from any industry, so typically there's a route which it follows to go to the landfill sites. Either it will be if judiciously that will be reused, or it can be finally it goes and gets dumped into a landfill site. So in such case, there are several examples where the mobile apps have been developed. Now these mobile apps are helping to map the various dustbins. Now if you have got the location of dustbins, no, this you can link it to the urban population, nearby urban population. So whether the dustbins are optimally located, whether there's a need of additional dustbins, that's one point. Now this, from that dustbin, the smaller vehicles as a paratransit kind of thing, no, they collect from the source and go to a transfer station. So now what should be the optimum route that this kind of smaller vehicles should follow for the primary collection? Now once this primary collection are there, number of primary collections are there within a city, how the truck should move from across all primary collection points to take you to the secondary location. So that's how using the mobile app, the such kind of waste management is feasible, right? So that the city remains neat and clean. We save on fuel and energy while this kind of waste is collected from various locations. So that is one area where the GIS, GNSS, and also the GIS can be utilized. So once this all material comes to the landfill site, then the question comes: the landfill site may be sufficient or insufficient, or additional landfill site selection has to be selected. That's how the GIS-based tools where the multi-layer modeling can be conducted. So when you're doing with the multi-layer modeling, certainly you require certain other inputs that will be either point information or the polygon-based information, right? So that's how, again, there's another area where the GNSS can be utilized. So with this all examples I have dealt with for a one and a half, 1 hour long session, no, I try to deal with what are the different kind of what is the need of GNSS in urban areas, what are the different kind of GNSS receivers are available, how these GNSS receivers can be utilized, and then when you are mapping with GNSS, what are the GCP's standards, right? And then what is the accordingly the need driven GCPs can be collected, and then when you are doing with the urban area, and then whether it is the georeferencing or assets management, you can collect either the point, line, or polygon based attributes. Once you have done it, then you can go on to the various kind of application. Several such applications I have cited here, but the list is endless because the time is a constraint, and as such, you and me, we have to come together for utilization of such kind of technology, because you know that though the urbanization, because the urban areas, they constitute only 4 to 5% of the land surface. Our country's area is nearly 320 million hectares. Only the 4 to 5% is under the urban areas only. But these all urban areas, they contribute significantly to the country's growth, because countries, though has got a agrarian society, but in terms of employment, urbanization is also inevitable. Industries are also inevitable. And that's how such kind of development can happen with the use of modern technologies like the GNSS, and this data can go into the GIS, and finally to lead to the digital India. And that is the mission and the program of Government of India, so that because we know that the growth story of India shall be written on the canvas of planned urbanization, and which requires sound digital database. And that's how the planners and engineers, they have to come together to write that script of that growth story. So thank you very much. Thank you to you all.